just go to the next slot in the agenda, which is let's say an overview of the platform, so that you have a better insight of what Fiesta platform is. It doesn't have, or you don't need to really understand it fully and go to the real details, but I think it would be useful for you to at least understand a little bit about of the system. Basically, you will be interacting whether with the APIs or whether with the portal interface, the graphical interface. But again, I think that it's always useful to get a bit of the insights of the system and how the system is structured. And this is what Rachid is presenting you in the next slot. Rachid, whenever you are ready,
so,
you can go through.
Yeah, I hope you can see a blank screen. So let me open the presenter mode. Okay, so what basically I will focus on is the experiment side. I'll just give you a brief overview of what the system architecture looks like, what you can do, and what are the components that we are using to actually have a successful experiment and run successfully the experiment on the Fiesta system. I'll talk about that, give you a quick short demo, what you can do, and in the next couple of slides I will also present my experiment that I have created. So Louis, one question from you. I hope I have like some time, at least like 1 hour, and divided it like session wise, but it's a complete flow. So if you're okay, I will take the session for the next one also. Okay, so I think you're okay. So to give you a brief overview of the ARC, I'm pretty sure that you quickly saw, and when Thiago was showing the Moodle, you quickly saw this figure. So basically, this is the whole Fiesta platform. So basically, the testbed side is the side which is below IoT registry here, and the experimentation side is, or the experimenter side is the side that is above the IoT registry. Note that everything in here is secured with the APIs and the system that Paul just described. So everything is secured, so that's why we actually did not include the security aspect here. So that's pretty straightforward. So I will not focus on the lower part, but on the upper part, where as an experimenter, I will tell you how you can write your experiment definition, which is basically the fetch spec, store it, and then execute your experiments on the Fiesta platform, which basically is IoT registry that holds all the data. And of course, how you can manage your experiments, and it's basically everything is. I'll talk to you about that. So I will give a perspective of the portal, where using portal you can do this. This is one of the things that we recommend. And of course, on top of this portal, there is also the APIs. So available, you can create your own system using the APIs that Paul presented, and some of the APIs that are available via ERM, EEE, or EMC that you see here. I will, of course, go into a brief of what these are, and let's see. Okay. So, yeah, this says we'll focus on the top part of which is basically the experimenter part, which is the part above IoT registry. See here. So, next. So, What is the flow of that we follow for experimentation within our Fiesta platform? So there are basically three phases. One is the design phase, the execution phase, and the evaluation phase. In the design phase, you basically have your requirements, you set your needs and everything, define KPIs, and basically that I think you guys have already done when you submitted your proposal. Then the next part is the execution part, which is basically you describe your experiment using the DSL that we have created. Execute your experiment, retrieve data, do further analysis. Once you have done your analysis, you do the evaluation, which is basically you evaluate your KPIs and decide if more advancements have to be done on your side or on Fiesta side and stuff like that. So, of course, doing this, you should follow best practices, and of course, we will help you define appropriate KPIs for your experiment and evaluate them together. So, what I will focus today is basically the execution phase, and I will go through all the steps that you actually need to follow in order to create a successful experiment. Okay. Okay. So what you have to actually do in order to create a successful experiment is first step is to create the experiment DSL. Set up a receiver at your site, at the experiment site, basically in your environment, in your company or in your institute or wherever you want, or on your own server. You have to set up a receiver which could receive data from Fiesta. Once you set up this, you log into Fiesta portal, access the services, upload your experiment DSL using the client, the register client. I'll talk to you about this and show you how to do this. That is available via portal. Of course, there are APIs also available. You can use them. And then save the experiment DSL. Once you save the experiment, you then go to open the management console, which is basically where you can manage your experiments. You open the management console, you select whichever experiment you want to execute, whichever service within the DSL you want to execute, and enable that so that execution engine could execute those services for you and on the IoT registry and send back you the required data. Of course, with that, in order to do this stuff, the strong emphasis is you should have the receiver installed on your site. So all services are available via portal. We have one scenario available for you to get a feel of the platform. But of course, as said, you can also use dedicated APIs that are available and create your own system. Okay, so I'll go into brief of what components we are using and how you can define the experiment and do the stuff. So for experiment definition, the experiment is actually defined using a DSL, which we call as FedSpec, Fiesta IoT Experiment Description Specification. This FedSpec contains two parts. One is the FEMO, which is the experiment modeling object. It is basically the metadata part and describes what your experiment is about. I'll tell you what all parameters and attributes are available in this FEMO. Then another part is the FISMO, is the service modeling object. It basically contains or defines your services that experiment needs, like, and it has the scheduling parameters, it has query parameters and other things. These FISMOs are actually tasks are created as threads or tasks within the Fiesta platform and executed by experiment execution engine upon the dedicated interval that is defined in the scheduling object. Okay, so what a FEMO looks like. FEMO is basically XML. This is a part of the complete fed spec that I'm showing. It's just describing the FEMO. The FEMO has the name, the description, the domain of interest, and different FISMOs that are attached to a FEMO. You can attach as many FISMOs as you want. You can have like one FISMO, or you can have 10 FISMOs, or as many as you want, but it should contain at least one in order to define your experiment. For domain of interest, these are IRIs of concepts coming from MVLite. So I will show you an example later. Then I will talk about my experiment that I have created, a demo experiment, you can say, or in-house experiment. And then, okay, so a FISMO basically is an object that defines certain attributes, like whether the FISMO is discoverable, the scheduling part, the location where the data has to be sent, and the query that has to be executed on the system, on the IoT registry. So for the discoverable, it can be either true or false. And this makes it easier for the execution engine to understand what and to tell other experimenters, reuse your experiment. I will talk on how this can be done. I will show you a demo. Then this, for the scheduling, the start time is basically the date time format. The periodicity is the integer value representing time in seconds, and the same like the stop time is also in date time format. This location is basically the location where you want where you want the data that the query the data that was received after the execution of the query is received to be sent by the execution engine. This is where the receiver that I was talking to you before comes into picture. So the location of that receiver has to be specified here. And then the exact Sparkle query that you want to run, that you want to execute it on the system. Currently, there are many other attributes that are specified, but in this first release and this first version, we only support just limited number. Of course, in future, as we move ahead, we will have more and more features coming in, and more information will be available, and more functionality will be added. Okay, so in order to create your first fed spec, some of the best practices are for the name, you do not put any junk like the test or blah blah or something. It has to be reasonable so that other people who, if you make your services or the FISMOs available as discoverable, so that they can understand what it is, and they can actually know what it is about. Same is for the description. Start time and stop time are in date time format, and stop time should be greater than start time. This is very reasonable, I think. For periodicity, you can set it based on your requirements. So if you set it to 10 seconds or 600 seconds or whatever, the experiment execution engine will execute your services or this FISMO that you have every after every interval periodicity that you have defined, or after every interval of those many seconds. Please do not provide it as 1 second because it might be an overkill for the system. Of course, we will be testing more and more the stability and how on large scale how well it is supported. But if you want to test it, please use it. Nothing important here. For URL location, it should be, of course, reachable. If it's not reachable, the data will not be sent to you, and it might be the case that you might complain, oh, Fiesta is not sending me data. So the best practice is to check first if the URL location is actually available and Fiesta is able to, or somebody is able to send this information to this location. Of course, you should protect your URL location, basically using IP. So Fiesta, if you want to restrict and allow only Fiesta to actually send this information, you should restrict it using either IP or that's the best option. So you should do that so that it's not available to everybody. And of course, for the query, do not do select star SPO. This is like we might block. It might be possible that it's blocked because select star SPO will return you everything that is there in the IoT registry, which of course you do not want because you are not using it. And this is where, of course, the evaluation of the experiment might be hindered. And of course, get your experiment evaluated. Okay. Now, so once you have created your fed spec using experiment registry module, you can actually store this fed spec into Fiesta ecosystem. So the module is basically called ERM. It's experiment registry module. It supports CURD based APIs. So create, update, remove, read and delete API features. It's supported by ERC, which is the experiment registry client, which is the UI to interact with these APIs. But of course, if you don't want to use these this client, you can definitely use the APIs coming from ERM. And for beginners, it is advised that they use ERC, which is the experiment registry client, to store the fed spec, and of course the ERC, but the portal to store their experiment. Once you have stored your experiment, the management console or the execution comes into picture. So whatever experiment, sorry, any questions? Okay. So whatever experiments are stored in the ERM, the execution engine and the management console reads those information and create jobs in the Fiesta ecosystem based on the scheduling parameters that are defined for each services. And they execute the query that on the IoT registry. Because the console is basically the UI that is provided to connect to experiment execution engine, and it basically helps beginners to execute the experiment. For storage, basically this is something that I have already talked. It's Currently, Fiesta does not store the results of executed queries. In the future, we aim to support this, but as of today, it's not supported. All the data that is gathered upon the execution of the query is sent to the URL location that experimenters specify. For the sake of help to the experimenters, we have created a very basic version of this receiver. It's available in the GitHub page of Fiesta. So you can go there and install this experiment server, data receiver that we have on your own environment. There are certain steps to be performed that you should follow in order to set up this server. As said before, you should enable, for security reasons, you should enable your Nginx or Apache to just accept data from FIESTA IoT platform. And of course, the default results that you will get will be in JSON format. Of course, in the near future, we envision to have different formats, probably in version 2 of the platform or the experiment execution engine. We will have different types also supported. So for correctly configuring this storage, the data receiver, currently what is being tested, it works well on Tomcat. So I have basically some configuration presented here for Tomcat to successfully run this data receiver on Tomcat. So basically, you go on the web XML and add the multi-part config with location. And this location is basically the URL location that you have. Not the URL location, but sorry, also not the URL location, but the actual folder where you want this data to be stored on your server. So you just provide that and make sure there's read-write permission for the Tomcat. In the Tomcat config content.xml, you just change it to allow casual multi-part parsing equal to true, and restart your Tomcat. And in the experiment service.java, where you have this file name equal to file location, you also specify this location of the folder where you want to specify the where you want to save the return or the files that, or the data that is received. It will be, of course, stored in a file, as you see here. Then compile and deploy it on Tomcat. Again, I have emphasized on security. So the current data that is received is basically JSON, and it has variables. So whatever select parameters are specified in the query, and the items that are available. So this is for select parameters. It can be a list of select parameters like lat, long, information, time, sensor, data value, and observation. So this can be one. And example of row can be lat information could be a value, lat, whatever value can be, and things. So of course, this will be the overall schema of the result that you will get as of now. For visualizations, of course, because we do not store any data currently, we do not support any visualizations as of now. But as said, in later stages, in later versions, we might go with the visualizations also. Currently, experimenters will have to create their own visualizations. Of course, note, you can actually create your experiment three ways. One is you perform the steps via that I talked about and use portal. One is that. Another one is you use the APIs and not use the portal or the UI of use APIs of execution engine, the ERM stuff to create your experiment, or you can directly contact to the open APIs of IoT registry. So those are the three possibilities. But as of today, I would recommend to use the portal and get the data, store your experiment using the experiment registry module, execute them using the management console and the execution engine, and get the data by installing the receiver. Okay, so some other resources that are available, as I said before, to query. The ontology is there, the documentation on ontology is there. You can create your own queries first. You can try to create queries using the IoT registry APIs. You can play with them and get desired results first, and then use them in your FedSpec or FISMO objects. And of course, there is this paper and the handbook. So for the demo, I will need 1 minute because I have to switch probably the screen and log in. So let me do this quickly right now. Okay. Okay. So I hope you can see the actual demo that we have. So this is the portal. I have all those that step. So I'm logged in as India, and that's my username that I have. Register client. Okay, so here in the register client, you have this open FedSpec and say FedSpec, so you can go open and select your experiment. I will do select experiment. I already have a couple of them, so I will not save it, but yes, of course, you can save your experiment. Export. Let me show you probably when I click on the new experiment, you can actually see the complete XML, the FedSpec that I have. You can export the FedSpec, store it, and you can of course delete your experiment. So once you have provided this experiment to the FIESTA platform, and using the client, the register client, you then go to management console. Here you see the different experiments that you have created, the different FedSpecs that you have uploaded. Currently, I have 2. You will see the ID of the FEMOs. Sorry, these are the IDs. Of course, you cannot see other experiment IDs because it's secured. So you can see only FEMOs that you have created, the IDs of those FEMO, the name, stuff. Just for this demo, I have created. Yeah. So the first time when you see when you log in into this management console, you will see all your services, all your FISMOs are not scheduled on the system. You have to schedule them basically. So I will tell you how you can do that. So first, okay, so the whole management console here is basically divided into 3 parts. first part is giving you some information about the demo that you have, the experiment that you have created, the associated FISMOs, which will be like in my case, I have 4 of them. And then you can also subscribe to other discoverable FISMOs. So here you can see all those FISMOs that are available. It's like list of lot of them. You can click on one of them and see, select. You can see what this FISMO is about. And in case you want to subscribe, you just provide the actual URL. So it's HTTP experiment. And once you provide a valid URL, the subscribe button will open, and you just click on subscribe, and it will subscribe the FISMO to your experiment, and will start sending the data which this particular FISMO has to the new location also. So let me go back here and quickly show the other aspect. I have to go to home. Okay, then go to management console. Can show more information. Okay, yeah. So currently, what I have done in one of my experiment is basically subscribe one of the available FISMOs, and this is where I'm receiving the information. All the services or the FISMOs are currently paused. You can resume a service. It will say service restarted, and you say okay, it will load, and the status of the service will change to normal. Of course, here you see that because you were the owner of the service, the tag is owner, and for the subscribed services FISMOs, the tag is subscribed. You can click on the name to see a snack bar which says, okay, what this experiment is about, and you can see here. If you want to so basically what this normal will status means is your FISMO is currently running on Fiesta platform, and the data based on the schedule, whatever is specified, the data, the IoT registry is contacted, and the data is received and sent to the experimenter. What you can also do is you can, out of the scheduling, you can get the results if you want to get the result right now, and you don't want to wait some period of time. You can just click on poll now, and this will send the data to this will run the query out of the schedule on the IoT registry and get the result and send it to the experimenter. I hope it runs. Yeah, so it says it's done and it's bold. You can also view logs of your past executions. So basically, you can see how much time it took for your query to be executed and the whole process to be completed, and what was the length of the data that was sent in bytes. And basically, execution time is in milliseconds. So mostly it was less time because there was less data and there was some data available. So it took more time. You can see most of the time. So yeah, you can check for different FISMOs. All of them were paused and not executing. So nothing is there. You can of course unsubscribe from a certain subscribed FISMO. This will delete all the references, and it should be yeah. Okay, so this was part of it. Then let me go back to the demo. So this is all these APIs that this console is using are available and are open for experimenters to use and create their own management console like. Okay, so let me go to the presentation of my experiment. Okay. Okay, so I hope you can see this. So what uh, I am doing is I have created this experiment, which is also the in-house experiment, and this is where I'm using the whole architecture or all the workflow that I have just described to receive data, and I'm using basically the portal to send it to submit the the fetch spec and the console to start the services and receive the data. So the experiment is about getting information about noisy places in the in the world, basically, because it's a large scale experiment that I envision. So it gets data from Sound City and Smart Santander from FIESTA and generates this UI. So the use case is basically what I want to avoid is noisy places while I'm going in, moving around in the city. So I just want peaceful and less noisy places. Only this currently this use case is available. So how I have defined the experiment fetch spec is in the FEMO. I have named it as in the experiment, which is basically large-scale crowd sensing experiment. The domain of interest is basically the transportation and the environment. These are, of course, comma-separated values. And one FISMO that I present here is the fourth use case. Fed spec, the FISMO object is basically the heat map of noisy places, which has noise more than X dBA. I'm running it at periodicity of 300 seconds. So after every 300 seconds, I get this data, which is like basically 5 minutes. The start time was in November, and it will run until November this year. But of course, I can change it and use it, extend it. The location is experimentalserver.org, which is of course fake because I don't want to reveal the actual location for security reasons. And then the query. I'll probably go to the query soon. So what all concepts I use from the ontology? I use basically the sensor, the observation instant, the time instant, the observation value, and the quantity kind, just for the noise. And it's mostly focused on the observation graph. The query, this is the query that I showed you before in the ontology presentation. This is the same query that I have here. It's basically getting all the observations where the quantity kind is sound or sound pressure level ambient, and then I get the most recent information and basically make it large scale, give the lat long for all the world, and add a filter which says, okay, the value should be more than 75 dBAs. So this is a Sparkle query that I have written. Of course, it might not be optimal, but this executes and works. So these are the steps in the presentation that I show you just before you can read the presentation. And sorry. And the final outcome is basically the experiment that we have. So here you can see this is basically Santander. So I have two noisy places that are displayed. Of course, this is some time back, but with more data to change. So yeah, that's all. Questions? Hello?
Yes, yes, we hear you, Rajit.
Okay.
This is not really a question. I just want to say that this looks really impressive. So well done, guys. And we are really looking forward to working with this platform. So it's more a comment than a question. So yeah, congrats.
So can I ask a question?
Yeah.
Yeah, just you explained the situation when you want like more.
Sorry. Just a quick comment. Can you come near to the mic because your voice is very low.
Okay. I'll try to speak louder. So you explained the use case when you need this data periodically. So what if you needed more runtime, like it's like when you really want to interface with user and user ask a query, ask a question which you want to translate to Sparkle and reply immediately. So are you assuming we will use API directly, or we'll still proceed with this like caching results by using this workflow you just explained?
Okay, so for cache, because there's this data updated almost very frequently, so there is no caching as of today because experimenters might be requesting new and new data. So there is no caching done as of now. Your queries are actually executed on the IoT registry. It might take some time depending on the query. This comes from IoT registry. So basically, it might take time. If the query is complex, it might take some time to execute. But when it's available, the result will be available to the experiment. So
okay,
what I did not. Sorry.
Directly using API is not really an option, right? So directly means runtime, like in response to user request, you don't really suggest to use API directly.
I mean, you can use APIs. It's not an issue, but you have to create your own system, like your own execution engine and your own receiver, and you need to create everything, your own ecosystem, basically.
Okay, thank you.
Yeah, I said something, Rajit. Rajit, can you hear me?
Yeah.
May I say something? First, Diego, thanks for your comments. We are really working hard. And regarding your question, we are going to present after lunch the way to directly attack the IoT registry APIs. And besides this, up to now, we have only implemented this kind of request response data querying. But I would like to say that in a couple of months, we are going to implement a kind of subscription system from which you will automatically receive the data upon it's injected to Fiesta from the testbeds. Okay, Vladimir.
Yeah, sorry, coming back on this. So just to clarify matters, so we shouldn't assume that there is a real-time engine behind it. I mean, it is something that you will explain afterwards, David, you mentioned.
Yes. The thing is that can you mute yourself because we are receiving some echo. The thing is that up to now we have only ready this request response system, but some a partner is trying to deal with this subscription system and put it available in the platform. Let's say the sooner 1 month, 2 months at most. That's why we haven't explained to you yet, because it's not it's pointless to explain something that it's not ready. Okay, the idea is to update the Moodle platform and the handbook every time we have something new, and let you know that it's there. But so far, this is all what we have. Okay, if you can stick to what we have for this first month, and then you want or you have time to upgrade to this subscriptions mechanism, the better. But in the meanwhile, I am afraid you'll have to use the tools that we are providing. Okay, Diego.
Understood. Thank you.